Relative gravity, abstract principles in the context of merging galaxies. Relative gravity incorporates abstract principles of physics, quantum mechanics, and object-oriented thinking. Below is an exploration of how RG's framework, through its elements A, B, and C, applies to the example of merging galaxies, framed through its definitions and extended concepts. 1. Abstract principles applied to merging galaxies. A. Potential energy is resonant frequency potential. For merging galaxies, potential energy is represented as the cumulative mass energy of each galaxy. This energy is expressed as a resonant frequency potential manifested in gravitational waves generated by their interaction. These waves encode the dynamics of their merger as oscillations in spacetime. The shared resonant frequency reflects their mutual gravitational influence, encapsulated in spatial time, a concept describing their dynamic yet sustained interaction over cosmic timescales. B. Resonant frequency as superposition. The galaxy's interaction can be modeled as a superposition of their gravitational fields. In regions of overlap, their combined fields generate new configurations, analogous to wave interference. The resonant frequency emerging from this superposition describes the shared dynamics of the evolving system, including orbital resonances and the eventual equilibrium achieved during the merger. This resonant frequency evolves as the galaxies move closer, exchange material, and reshape their structures. C. Unique dispositions of bodies' potential. Each galaxy's unique disposition, defined by its mass, rotational velocity, dark matter halo, and stellar populations, dictates how its potential energy is expressed kinetically during the merger. Examples include formation of tidal streams, creation of a central black hole, redistribution of stars and gas into new structures, such as elliptical galaxies. These kinetic expressions are not uniform, but instead tailored to the specific characteristics of each galaxy. 2. Superposition in spatial time in merging galaxies. Superposition as a dynamic interaction mechanism. Gravitational fields as superposed states. The galaxy's gravitational fields combine in a manner analogous to the principle of superposition in physics, creating a vector sum of forces. This shared field establishes a transitional state, influencing both galaxies' trajectories and structural evolution. Spatial time as the interaction's context. The interaction unfolds within a defined spatial time, a period during which the galaxy's relationship is observed and their properties become interdependent. This aligns with relativity by framing the interaction as a shared frame in which forces and energy exchanges are measured. Now, 3. Relativity and inheritance in object-oriented terms. Relativity as a relationship between similar entities. The galaxies as massive bodies share a gravitational relationship characterized by symmetry in their interaction. Their shared traits, such as gravitational influence, are inherited from the fundamental principles governing mass-energy interactions. Polymorphism and symmetry conservation. The merger exemplifies polymorphism. Abstract gravitational laws manifest concretely in phenomena such as orbital decay, bursts of star formation, and tidal disruptions. Symmetry conservation is evident in the way properties like angular momentum are distributed and preserved during and after the merger. 4. Superposition and the measurement paradox. Merging galaxies exhibit a quantum-like duality. Before precise observation or modeling, their trajectories, outcomes, and structural changes exist in a state of probabilistic superposition. Measurement or simulation collapses this state into defined possibilities, solidifying their observed dynamics. This quantum analogy underscores the abstract nature of relative gravity, suggesting that even macroscopic phenomena can be understood through quantum principles. 5. Key contributions of the relative gravity framework. Unified description. Relative gravity links merging galaxies, gravitational waves, and quantum phenomena through a shared framework of spatial time and superposition. Abstract relational dynamics. It provides a novel conceptual approach to relationships between entities, extending classical and quantum mechanics using object-oriented metaphors. Inheritance of symmetry. The framework demonstrates how properties like force, energy, and time persist and adapt across varying scales and contexts. Conclusion. The relative gravity framework offers a powerful lens for unifying physical phenomena across scales from quantum particles to cosmic structures. By embracing abstract principles, spatial time, and object-oriented thinking, it bridges classical and quantum mechanics with innovative relational insights.